Alright, gonna use a rapid strip just to get that outer edge there. Alright, I figured I'd give you a little quick update on the faceplate. As you see, I've been cleaning it up, wire wheeling and polishing, and it's looking a whole lot better than it was. I had to come inside because we're actually getting ready to have some rain come through, and it started sprinkling outside, so I just kind of rolled it in here. But we're pretty much done with the back side and the outside diameter of it. I used a wire wheel to knock off all of the real thick fuzz and rust, and then I went back with the Norton rapid strip polishing wheels and slicking it off, getting all that coating of rust off of it. Still got a couple spots in here that I need to touch up with the wire wheel that I missed, like right there. There's still a little bit of crud up in there, and I still got to get in these slots some too. But we've got the threads wire wheeled out. And you can see I've got the face left to do and the T-slots and things, so I'm going to go ahead and get started on that now. See if I can get some of it done. How far I can get anyway. But my main thing was just the center bore. I wanted to get the threads cleaned out. But I wanted to go ahead, after I did that, I was like, hell, let's go ahead and start cleaning it up. But it's looking good though. It hasn't looked that clean and who knows how long, how many decades it's been. So we're going to keep cracking at it. Alright, we're getting there pretty dang close to being polished up. I'm still going to go over it a couple more times, but the majority of it's done, but I still got to get into the T-slots. So I found this little wire wheel here, and this will actually reach down in the T-slots here. And I might be able to get a little bit of it cleaned out with this, but see, like my cut brush, this is about all I got besides a bigger one of these. These won't fit. So I've got to try to come up with a better way to cleaning those T-slots out. I'm not sure exactly what that's going to be yet. Might be just a different kind of wheel that I don't have already. So we'll see. But I'm going to do some more with the air grinder. I pretty well got her cleaned up. I've still got a little bit of detailing that I got to do to it, but what I want to do is go over it with a fresh rapid strip wheel. This is what I've been using, Norton Blaze rapid strip. Seems like a new wheel, a fresh wheel, puts a better sheen on the surface. So I've been using the two old wheels. I've been using those up, getting it all polished and clean. And I'm going to go with a fresh wheel and see if we can get a little bit better polish on the face of it right here. And then once we do that, I'll be pretty much done with this. But I need to find, I'm going to buy me some smaller wire wheels to use in the air grinder to kind of get in there and do a little bit of the detail work. It's putting off more dust than what I thought, so I'm going to go ahead and put my mask on. Well guys, I think I pretty well got her cleaned up. What I've just done was I went over the back here, you know, even though I wire brushed it and everything, it's still dirty, so you got to clean it. I wanted to clean it and try to get all of the, you know, all the dust off of it. So I use my little zip sprayer here with my fast evaporating degreaser. You know, just spray a little on like that. Go behind with some rags and just kind of wipe it. You wipe all the dust and everything off of it, you know, and then that dries really quick. So that's what I've been doing, is just kind of cleaning it. You know, like all the little corners here that's hard to get with the wheels and the wire wheels. Just been wiping it up. And I got this this bore. I got it wire wheel pretty good. Went in there with that small one, and I got all those threads pretty well cleaned out. And you know, they look good. They're polished up, but the condition that they're in, as far as the metal, I don't know if it was just a rough ass casting or what. I mean, because there's a lot of. Let me see if I can get you a shot of it. It's kind of a bad angle, really, but I've wire brushed them. I've wire brushed them so that they're free of rust and dust and dirt and all that kind of stuff. So I can machine my shaft to screw in here, and I'm not worried about how clean this is. So that's done. So what I'll probably do now, I've got the rest of it polished up. I think now it's time to go ahead and spray it down with a coating of oil. Now we're starting to get some rain coming through here. I've been working with my door open so that the dust can ventilate. But it's probably time to go ahead and coat her down now with some oil of some sort. I've still got to finish wiping it off from the front, you know, the front side here. You see where my cleaner dripped through. So I need to clean it good again. Wipe it off real good, and then I'm going to oil it down. Well, that's pretty much a wrap on the cleaning up of the faceplate there. I got her oiled down now. That's why it might look wet. I decided to use WD-40 on this instead of some of the other stuff. I've got Stearit oil also. Stearit oil works good, but it leaves a thicker film and kind of attracts more dust and everything after it sits a while. It shouldn't be trying to rust up on me unless I, you know, have the door open when it's real humid outside. But the once it coats itself good with that WD-40, it kind of soaks into the surface there. It should be pretty good to go. And you got the backside also there. See, it's kind of wetted in. So I'm just going to let it dry. Most of that should kind of dry up. But yeah, that's about it. So the I wanted to get the center of it cleaned up so that I can go ahead and get ready to start on the rest of the shaft work down in the lathe, get it turned and threaded to fit inside there. So while I was doing that, I just said, heck with it, let's go ahead and just get it cleaned up and get that part of it done. So that's what I did. So I'm happy with it, you know. And it's been a very long time since that faceplate has been that clean before. There's no telling how many decades that thing was rusted and dusty like that. But I'm happy to see it clean, man. It makes me feel so much better that it's finally cleaned up and it's not sit there just full of rust. All right, well, that's about it, guys. We'll see you on the next round, okay?
Today is March the 30th, 2016, and I want to show you an antenna that I've recently built. Got it up yesterday. Well, actually I got it up a few days ago, but I had to pull it back down to make some connections a bit tighter because the wind here in El Paso has been really brutal lately. What it is, it's a rotatable dipole. I'll show you these pictures first, and then I'll go ahead and show you my thoughts on it. There's a little choke up there, a little air choke, whatever you want to call it. It's oftentimes referred to as a balun. It's not really a balanced to unbalanced transformer, but it does serve that purpose. That little string hanging down there I will cut off later. I have to climb back up there with a knife out on the end of a stick to cut it off. So that's a little unsightly at the moment, but it's not harming anything. Let's see if we can, how close we can get here with the camera. There we go. You can see where it's, the coax is connected. The center element, the center of the coax is connected to the left side, and the shield is connected to the right side. That's a 9-foot piece of, it's actually called RG9 BU, but it's just 50 ohm coax. It's just a really high quality double shielded, silver plated shielder at it, and then it comes straight down. There's a rotor. Now I realize I don't have any front to back. The front is the same as the back, but it does give me a good 4 to 5 S units of attenuation off the ends out here in that direction. Right now it's pointed south, north and south at the same time. I love it. This thing is so superior to that G5 RV that I had that it's hard to compare. It's up the top of the tower right there at the bottom of the rotor that's 30 feet. It's lifted about 2 feet up in the air on some cement. So I guess I've got it up close to 35 feet. So let's go inside, and I'll show you some of my thoughts on it and what I've done. The way that I determine the length of the element is by the old formula 468 divided by the frequency in megahertz. Or if you 468, or if you want to use inches, you just multiply that times 12, you get 5616. You divide that by, I cut it for 14.25, 14.25. That gives me 394.11 inches. I'm just going to do it in inches and let my European friends that do metric system figure this out. I know that it's pretty easy to convert. And you divide that by 2, and you get the length on each side. Now there is one little thing that I have found important. I've made a lot of antennas in my life, and I found that what you need to do if you're making it out of something besides wire is you have a length to diameter ratio. And here is a chart. I don't know what I got this out of, but I thought it was so important I made myself an extra copy and laminated it. It's called a graph of element diameter versus length. Well, it's 1 1/8 inches, and then it tapers down a little bit to 1 inch. This is an OD, and then it tapers down to another one, which I don't remember all of these dimensions. But anyway, I estimated it at 1 inch. So I have a ratio of 1 inch to 394. Well, I call that 400 to 1. And if you look here on these charts, a ratio length in ratio of length to diameter. See, it's a logarithmic chart. 2, 100, 200, 400 right there, and you go out to here, then you get about 0.95. So you want to shorten it about 5% because of its diameter to length ratio. So if you shorten this to 0.95, you say 0.95 times, that'd be 374.4 inches, and divide that by 2, and that's what it is on each side, 187.2 inches. That's what I got right here, 187.2 inches each side. That's the way I did it. And there's Miss Kitty Cat coming around to check my numbers. So that's the
length on each side. I'll have to go get some of the parts, and I'll show you what I used as an insulator, and it turned out really nice. But that's where I determine the length, and I've done this a number of times with Yagis, which I've built quite a few of in my life. Never keep them a long time. I don't know why. I move or decide to make them better and then end up messing them up or something. I don't know. But this one I'm really pleased with. I've got it on an old rotor over here. Right here. I mean, this thing is ancient, but it still works. One of the things you might be interested in, this wire right here that I use is 10 conductor. They use it for sprinkler systems. Irrigation wire. I can get it at Lowe's. It's 10 conductors. So what I did is, it takes 2 wires to unlock the brake, which needs to be larger. I put 2 of them parallel and 2 more parallel, so that I got larger wire. Number 18, 2 number 18 wires parallel gives you the equivalent of a number 15 wire. I know that's a little bit of an odd number. Like 2 number 18s don't give you a 16 or a 14. It's a logarithmic scale. Wire size is a logarithmic scale. So 2 number 18s parallel gives you a number 15. You can look all this up on easy enough in American wire gauge charts. So that's what I used, and the wire, this rotor wire, wasn't too expensive. And from here to the rotor is about 130 feet, and it works real good. Watch it turn here. Just works really nice. I'm really pleased with it. I was just in QSO with a gentleman up in Iowa. I'm running this thing with the amplifier off the old S line here, and it's just doing marvelous. Like I say, it greatly outperforms my G5 RV Junior. I've already taken the G5 RV Junior down, and it just so happens that the night that I was on late, I did have some contacts. I'll show you right here. I've just started using the QRZ website, and I had 2 contacts. Oh goodness, I don't know. I don't want to fumble too much and find it. One was from Ukraine. One was from Brazil. I have to fumble too much. I don't use this for often enough to find things easily. I was looking for my logbook right there. Yeah. See right there, a UW2M and a PX2B in Brazil. The other guys are more local stuff, but those were the 2 contacts I made that night. It was exceptional. I think it just seems like all of the spirits conspired to help me that night to see how well it worked. But let's get back to the details of the amplifier. I've got to go get a part, and I'll show you what I used to separate it and my thoughts on the choke. Here's the centerpiece of the antenna. This is an exact duplicate of what I have up there, where the tubing, one half of the element goes this way, the other half this way, and then you connect together. You connect the electrical point through these screws right here, and the coaxial choke that I use is 9 feet of, I believe this is 9913. Just a good quality RG8 type, whatever you choose. Now, I've seen a number of articles and videos on these air chokes, and they seem to say that anything random between 10 and 20 feet is good, and it probably is. I don't really know if mine are any better for what I build them for, but just a random length of wire, I know I'd never be satisfied with it. So I posted a video sometime back about why I choose 9 feet, and it's just for 20 meters, and it works great, and I can prove it. We'll go down in the basement here in just a second, where I've taken that General Radio RF bridge, and we'll actually measure it. That's the fun part. I'll show you how it turns out. Okay, we're going to use the this GR 916. What is this? A 916A, I believe it is. Impedance bridge. I've got the transformer in it for the 3 to 60 megahertz. Beautiful instrument. I love this thing. What I'm doing is I'm putting in just the tiniest of signal as I can into the input. What I'm using is this little Tentec Argosy right there, and I've got it the RF output turned all the way down to 0. It still puts out the tiniest amount, and I put it in CW mode so I get a little bit of drive. And then I've got my receiver over here tuned to 14.250, and you'll see what that does here. Let's see if we can watch this thing, if I can stay out of the way and at the same time show you how it works. I'm going to put in some carrier. You hear that, of course. Then we set this to 0. We set this to 5,000, and it's a capacitive. I've already checked all of this stuff, so I've already gone through this. You set this one to 5,000. You set this one to 0, and then you null it. See, you can null it all the way down to hear the crickets. Well, let's see. I still hear it a little bit. Okay, I think I got it there. Then you take, it's going to get really loud. Take this thing off. Hook the antenna to it. Now, without touching these again, you make your measurements. See, that's about as low as that one will go. Then we do the reactance part. I think that's about as close as I can get. Now I still hear it a little bit. Anyway, I'm splitting hairs now. And then this thing's a little complicated to read. Kind of important to see it though. So I want you to. You're probably not going to get to see too many people use one of these things on YouTube. So you null it at 5,000. And then you null this one at 0 in the capacitance range. In the inductance range, you null it at 0. Now the way you determine the amount of reactance in the capacitance mode is you take the number that's on there, which is like 4,600, and you subtract it from 5,000, you get 400. And then you divide that 400 by right here. See, it says divide reading by frequency in megahertz. And then this one is a direct readout of about 27 ohms. Well, here it is right here. It's 27 ohms. And once you do the 400 divided by 14.25, you get 28.07. So what you get is 27 ohms minus J 28. It means it's a little bit capacitive. And if you do a scalar Z, it's this squared plus this squared and the square root of that, which is 39 ohms. And if you compare 39 ohms to your 50 ohm coax at this end, I realize that we're always trying to adjust the antenna, but I can't get all this equipment up there. I get 1.28 down here. At 1.3, I get 25 ohms minus J10. That's an SWR 1.85, and at 14.2, I get the same thing. 14.2 and 3, I get the same. Well, SWR 1.28. It's a little bit lower, but anyway, yeah, these two are the same. from 14.2 to 14.25. 14.3 it starts rising a little bit. Maybe it goes down a little bit better below 14.2. I don't know. I'm not really concerned because I use an antenna tuner to tune that little bit of reactance out, and I get 50 plus J0. I'll show you that out of another little instrument I built. I hope it's down here, so I don't have to go chase that thing down again. And a little RX bridge that you might like. Okay. Lastly, I think here's a little RX bridge I built a long time ago. I believe I got these dials off of, I think off of an old Heathkit instrument, and I painted them and renumbered them to suit myself here. I'll show you the schematic in a minute. It's pretty simple, and we just dial these things in till we get a null. I will say, if I had to do this over again, I would probably use a little bit, probably use like a 1 milliamp meter movement. This is a 20 microamp. See, 20 micro, and it's real sensitive, almost too sensitive. Picks up a little bit from the antenna, but anyway, let's keep going here, and then we start measuring the R and the X. Yeah, making sure you're in the camera, and we end up very carefully here because the meter is very, very damped. Okay, I think I got it. I think I can quit. Okay, see, it measures about somewhere between 22 and 33 ohms. I believe you can read that. We'll call that 25 to 27. And then it has a capacitor of 500 picofarads. That's the equivalent of what it would take. So we get about the same number we did a while ago, somewhere halfway between 22 and 33. 22, it'd be like 5 to 6 more. So if you add 5 to that, it'd be 27 to 28 ohms. A while ago at 14.250, we got 27 out of the nice GR, and the capacitor would be the equivalent of 500. The reactance would be that of a 500 picofarad capacitor. Now we actually have to do X sub C to get that one. I know this stuff is crazy, but that's 1 over 2 pi FC. That's 2 enter pi times F 14.25 E6 times 2 pi FC 500 E12 change sign time reciprocal 22 ohms. So in this case we get 27 minus J22. 27 minus J22. Let me write that down. 27 minus J22. That's what we get with our little homemade meter, and that with the nice GR we get 27 minus J28. Pretty good, huh? For a little simple RX bridge. And here's the schematic of it. You can find these things online. Hope this thing is focusing. This is that pot. It's a 100K linear pot. You need to when you build it in there, you need to put it up on the little plastic insulators and put a plastic shaft to it. You want to insulate it as best you can, isolate it the best you can to minimize the stray capacitance. This is a 250 picofarad capacitor, and this one right here is exactly half. That's what makes it balance right smack in the middle. So whatever this one is half. So you have to play with them. And instead of a 100 ohm resistor here, I used actually a 1 millihenry choke. And that's it. Yeah, you can look these things up. Oh yeah, this little coil right here was I had to build that thing several times. I remember that as long as it's been. I don't have a date on here. This is probably back in the 80s. And I used 3 number 28 wires, and I twisted them tightly, and I wrapped 5 turns around a little, I set a small toroid core. I didn't use a toroid core. I did it one time, but I ended up changing it to one of those little powdered iron cores out of a, you know, like out of a slug. I'll show you inside. I believe I took the screws out of the back. So this thing works pretty good. It's only good up to, really good up to about 20 megahertz. But it'll do all the HF bands, you know, up to 15 meters. It won't do 10. I believe I took the screws out so we took this thing off. In case you're really interested in building one of these things. See, this capacitor right there is the one that's exactly half of this variable one. And there's that little transformer. It's about 6 inches of, 3 pieces of number 28 wire, about 6 inches long. Twist them together with a drill, and then distribute them out according to the schematic. There's that little 1 millihenry instead of the 100 ohm. There's a capacitor across it, and 2 diodes too. You know, help make sure I don't blast my meter. Anyway, there's that thing, 1.5 volt max. Okay. But anyhow, I'm really happy with that. With the rotatable dipole. So I hope you enjoy this. Hope it encourages others to build things and make measurements. And if you ever, you know, run across these old GR instruments, pick them up. If you love this stuff, I do, because they're just magnificent instruments. Thanks for watching.